I like it. The rest of you are just party poopers, huh? Okay. Well, I was trying to make it easier because you already had seen them once. You'd already talked it through with other people once. And you'd already gotten confirmation of a right answer. Now, does that mean you all had it memorized from yesterday? No way. But I just was curious if you could repeat the process or if you could remember what the answers had been. So real quick, make sure that you wrote the word factor because that's a quick reminder of what the word means and what you're supposed to do. The reason we were doing them in homework was because, oh my goodness, if we can get it in factored form, that's the algebra way of saying it. The graphing way of saying it is intercept form. Man, our graph gets so much easier. If we can get these guys, if we can get these factors, our graph gets so much easier because we can graph P at 0 and we can graph Q at 0. Remember, signs backwards. We can use that nifty formula, P plus Q over 2, to find our vertex or the axis of symmetry and then plug it in. You guys did great at plugging in, at least knowing to plug it in yesterday. And the vertex will either be up if it's a down, or it'll be down if it's an up. And man, we have the graph right there, but we have to factor first. So, on the first one, I don't want to call anyone out because you weren't working with anyone today. You were just trying to do it on your own. So I'm taking volunteers. Does someone think they have the correct factors for number 1? Raise your hand fast. Levi, what'd you get?
X plus 3x.
Times?
Times x plus 5.
Okay, and the snazzy math is perfect. It's great. The snazzy mathematical way of saying things like the parentheses, we don't usually say like parenthesis x plus 3 parenthesis, which he didn't. But still, how do you kind of say with your words that there are parentheses? You can use the term the quantity. Quantity kind of means, hey, this is going to be a group, the quantity x plus 3 times the quantity x plus 5. Actually, if you want to be super snazzy. But yes, those are the correct factors. And if you were to multiply, you would have gotten x squared plus 3x plus 5x, which is 8x, plus 15. Perfect. Perfect. Number 2, another volunteer. Andrew Bosch.
X plus 7. X minus 1.
Okay, your guys' turn. Is he right or is he wrong? Max. What do you think it should be instead? Why?
Because it's 35, negative 35 is bigger, and 7 is
X minus 7.
Okay, well, negative 35, wait, pause. Does this give me a negative 35 right now?
no.
Careful. A positive 7 times a negative 5 is a negative 35. You're right that the sign should be flipped. That's because of what Kayla is saying, which is?
Well, because if you multiply, or if you're subtracting negative 7 minus plus 5, it would be negative 2. And it's supposed to be
Yeah, it's supposed to be a negative 2, right? And so negative 2, I don't need a positive 7 minus 5. I need a negative 7 plus 5. So, I think maybe, Max, you were thinking the right thing. You just kind of explained it a little off. So either one would give me the negative 35, but only this correct sign choice would give me negative 2. I needed negative 2. Does that make sense, guys?
Yeah.
X squared plus 5x minus 7x minus 35. And if you were doing the x method, hopefully you would have been able to double check that you had those correct because you would have written maybe a negative 5 and a 7 and been like 7 minus 5 is positive. Oops. Now we got it. Okay, number 3. Someone else who hasn't talked yet to, Max wants to take it. Go ahead.
That would be x plus 2 and x minus 6.
Let's check it. X plus 2 and x minus 6 does give me negative 12. Perfect.
Okay.
Does it give me positive 4? Exactly. So Alexis, what should it be instead?
negative 2, positive 6.
Yeah. And Max, do you see it, how that would work? So x minus 2, that would give me a negative 2x, plus 6 would give me a positive 6x, 6 minus 2, positive 4. Got it. Okay? Last one. Ooh, do you guys remember the special one? If you were doing your X method, this one's tricky because you have to put a 0 at the middle because it cancels out. But Danny, what do you think?
X plus 9, X minus 9.
Is he right?
Yes.
Yeah, he is. X plus 9 and X minus 9, you have to think about the square root of 81. What number times itself would give me 81, and if the signs were opposite, would add to the 0. Dun, 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 dun. They're called differences of squares. Okay, just curious. Just curious. How many of you guys got at least one right? At least, which means 1 or 2 or 3 or 4. Stand up. Come on. People were falling asleep yesterday. Stand up. You got at least one right. At least one. Stand, 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 stand. Come on. Party poopers.
I got all of them.
At least one right. You got at least 2 right. Stay standing.
Oh, wait.
You got at least 2 right. Stay standing. At least 3 right. Stay standing. All 4 stay standing. Woo!
All right.
People still standing, give a high five, and then give a high five to someone sitting, and then grab a seat. Come on, high fives all over. Way better factoring than we were like last semester. But pause.
Ow.
Okay, watch the extra. I just said high fives, I didn't say talk. Sure. Problem is, for last semester, not for right now, for last semester, were these the easier factoring or the harder factoring? Easier. I'm not going to say easy, but easier. Why? What did every single x squared have in front of it?
Squared.
1.
A 1.
1.
Let's see.
But could a 2 or a 3 or a 4 or a 6 or a 12 sometimes show up?
Yes.
Nice thing is, though, in homework last night, 8.5b, the one I'm going to come around and check with 8.5a in just a moment, were the factoring problems the easier ones or the harder ones? Yeah, they all had 1s in front. So I was very careful to make sure we only practiced the easier ones. We'll get back to the harder ones at some point. We just didn't need it yet, which is nice, because then for the test on Wednesday, we're going to have the easier ones also. Sound good? Okay. Doesn't mean you guys are like masters, but you're doing a lot better than you used to. And I think that we're slowly, gradually starting to figure out factoring. All right, cool kids. You have in front of you, I believe, section 9.2 practice page. Yeah? You have section 9.2 practice page. I need you guys to write a couple notes to yourselves, and then those of you guys that take notes should be everyone, but at least we're all practicing on the worksheets. At least we're all somewhat trying. I'm going to get you started on the problems 1 and 2 because they're actually, once you understand what it's asking, they're actually pretty nice. And then I'm going to have you go ahead and get notes ready for today as I come around and start creating 8.5 A and B homework. But I need you guys to write down a quick hint to yourselves on this worksheet first. Ready? Do we all have the 9.2A, the one I passed out today?
Yeah.
Are some of you realizing that you might have to change your organization a little bit to be able to keep track of these worksheets and not lose them?
Yeah.
Do you need maybe a math folder? Do you need, or can you? Do you have a homework spiral with a nice little folder? You can just keep them all in there. Some of you are a yes, some of you are a no. We could always, there is a way in your composition book to kind of make like a little file folder with a little bit of glue. I have glue sticks up here and a piece of paper that's folded just right. You can actually make a little folder, which is actually kind of nice. You can keep it in there, but let me maybe show you how to do that tomorrow. If some of you need to make a folder in your composition book, but otherwise, most of you have binders, most of you have folders. We need to be keeping these worksheets safe, not only for the grades of me checking them, but also for studying for your test. It's a great thing to use, yeah? And quick, just with a raise of hand, have any of you used any of these worksheets yet to help you on homework?
Oh, yeah.
Right? Like, they're helpful. They're the basic problems that you're doing. So, anyway, it's helpful in so many ways. Okay, on your practice page, on your worksheet, the directions say, use the graph. Oh, they're given to us. Yes, please, right? Use the graph they're given to us to solve the equation. What? You went, Check it. Ready? What am I asking you to do on the graphs? Find the x-intercepts. Because we learned yesterday, what's another word for x-intercepts? Do you remember? It is the points where it crosses the x-axis, but Melanie, what's the other word for it? Yeah, The zeros of the function. The x-intercepts are the zeros, and guess what? Ready? The zeros are, aka the x-intercepts, the solutions to equations. Are the solutions of the function, or are the solutions to, well, wait a minute, hold on. So if they're saying use the graph to solve, don't I want to find the solutions? So couldn't I just find the, which are really just the,
X-intercept.
all I have to do is find the x-intercepts?
Wow.
So you guys are going to find the x-intercepts to number 1 and to number 2 using the graph and the what's labeled. No, careful. Guys, this graph, number 2, does it hit at 4?
Yes. No.
You would think because the number 4 is written, but count it. Is
Oh,
it
no,
4
no,
this slash and doesn't it hit here and here?
Yeah.
Okay, so be careful. You got to read the graph. But I want you to find the x-intercepts because those are the zeros which point you to the solutions. Ha! And as soon as you've done that to 1 and 2, then I want you to write down our goal for today. And maybe you can even start to answer what we need to fill in. Ready, set, go. And as you do, I'm going to come around and check A and B. So get your homeworks just kind of underneath the worksheet, ready to go, ready to show me. Get your homeworks open and underneath. And you're finding the x-intercepts of 1 and 2 and then starting your notes for the rest. I'll check it next time. I didn't think about that. Okay? But does that make sense when it's about how you're Pause the video, guys. I don't think anyone who's absent needs to hear you. Solving the equation. Solving the equation. Find the x-intercepts. Everest. Ah! Not yet! I was so excited you had an answer. Max. Huh? -1. Oh, careful, not -1. It's on this side, right? So we have +1, 0 as an x-intercept. You see it? 0, 0 is that little crosshatch in between the x and y axis. And then what's the other one? -4. -4. Yeah, careful. We got to make sure we're being precise on that, right? -4, 0. What are the intercepts for number 2?
2 and 5.
2, 0, and 5, 0, right? So we have 5, 0 being over here. We have 2, 0 being there. And I think so far both of these graphs are just going by ones. Do you guys agree?
Yes.
Okay, they're labeling every other, but they're still going by ones. Now, here's the crazy thing. Remember I said x-intercepts are the zeros, are the solutions. We're done. Almost. X-intercepts are points, right? X comma y, and the y is always 0 because it's hitting the x-axis when y is 0. The solutions, well, do you guys see any y's in these equations? Ever see, Andrew, come on, focus.
I mean,
Do you see any y's? Like literally, like the letter y?
no.
No. Do you see an f of x or g of x? That's snazzy notation for y. No. Well then, guys, in algebra, if we're solving an equation, aren't we solving for the variable that's there? Who's there? I can look at the x-intercepts and I can just use the x's as the solutions.
That's the answer.
Oh, okay, no, I got it.
If you plug in 1, it would be 0, check. And if you plugged in -4, it would be 0, check.
Okay.
See it?
Wait, so that's the answer? Oh, okay.
So wait, solutions are, well guys, in algebra we always get x alone. But we're kind of cheating because we're saying we can see the graph. And the graph has zeros, has intercepts at -4 and 1. I know the answer, -4 and 1.
So when you find the x-intercept, that's
You're finding the solutions. See? Except they're written differently because the solutions aren't the points. The solutions are the x's of the points, of the intercept. So what would the solutions be for this one?
Could it be either way or?
Yeah. We're just kind of listing them. So 2 or 5, 2 and 5, 5 and 2 either. But normally in math, like I like to write them in like ascending order. So over here, let's give ourselves a note then. If we're trying to find solutions, now check it by graphing. Remember, that's why we're doing this weird section from chapter 9, because it uses graphs, and that's what we've been doing. 8.4, 8.5, graphs. If we have our quadratic written as, well, actually, you know what? You guys just told me there weren't any y's, right? Okay, so hold on. It doesn't have a y equals. Instead, it has this guy, intercept form, set equal to 0. If we're trying to find solutions, okay, of an equation like this that has intercept form equal to 0, the cool thing is, all I have to say is, well actually, the crazy thing is, even if we have, bless you, something like this equal to 0, and we have the graph, either way, we can say that x equals p comma q. But another way of saying that is, or x equals each of the x intercepts. And that's exactly what we just did. Now, the bummer of these two is that the equations weren't factored, weren't written in intercept form, weren't written like this. If they were, we would have just been like, steal him, opposite sign, done. But it was written like that, which is kind of nasty, but the nice thing is we have the graph, so all we had to do was find the x-intercepts and say, booyah. X-intercepts, booyah, done. Now, what's going on? Do you guys see any other graphs in that entire worksheet?
No.
Oh, do you see grids for graphs though?
Yes.
Where's that at? Numbers?
5 and 6.
Oh, the directions say solve by graphing. Oh, but I don't have a graph. Does that mean we have to make it ourselves?
Yes.
Okay, but pause. What's before 5 and 6? There's something in between with no graphs. I kind of like that. Okay. 3 and 4. 3 and 4. Oh, hey, I got it. People in notes, you ready? Or people taking notes on the worksheet. You got it? Here you go. What do these directions mean when they say in 3 and 4? Write the equation in, oh, it's right here. Standard. Oh, I got it. I'm about to answer. Standard form of a quadratic. All it means is get it to where the x squared guy goes first. The x guy goes second. The constant goes last. And get 0 on the other side. Now, we kind of already saw this last semester a little bit when we were working with factoring. In some ways, I think what we did this semester should have maybe come before all the crazy factoring stuff from last semester. The book has it come way later. I think it might have been easier before, but hey, we don't mind starting the semester off with some nice, easier stuff, right? Or maybe not. Maybe we should start with the hard stuff. Anyway, I like starting it with the easy stuff. We've actually done this whole solving for zeros before. It was called Moses splitting the Red Sea. But we don't even really have to worry too much about that if we just kind of restart this whole thing. So they're just saying, let's solve by graphing. We can steal the x-intercepts. Those can be our solutions. But before you even think about doing the x-intercepts, sometimes they're not written in the right order. So we need to rearrange. Now, careful. We need to rearrange. Legally. Oh my goodness, that's the hardest thing in math. Rearrange legally with our algebra skills. What do I mean by algebra skills? I'm not going to write it up here because it's not exactly the same type of problem. I just need your brains to think about the following. Ready? Do you have algebra skills? Yes.
No.
If you can answer the following question, and I'm pretty sure most of you can. If I said x minus 10 equals 2, what would you think of doing?
12.
Add 10 to both sides. You have algebra skills. Why? Because you know, number 1, to get x alone, and number 2, you know that you can move something in algebra from one side to the other by just doing the inverse operation. Subtraction, you add. Multiplication, you would divide both sides. Division, you would multiply. Okay, you guys have algebra skills. So if you have algebra skills, use them here. Now here's the crazy thing. Someone said right to left, left to right. I don't know. Someone said that. We don't really care which side it ends up on, because there's this snazzy property in math that you guys memorized way back when, thought it didn't matter at all, that says if A equals B, I can rewrite it as B equals A. If something ends up on the wrong side, no stress. Write it the way you like it. It's fine. Equality goes both ways. Okay? So if that's true, if I can go either way, and if I need all the guys on one side with 0 on the other side, does anybody have any ideas about what we should move for number 3?
3. Divide 3 into 15.
That would be the right thing if we were solving for x. But what are we doing? We want my big old quadratic on one side, and I want 0 on the other side. If I divide by 3, I don't think I'm getting 0. The way to get 0 is to subtract or add away, to have something cancel. Subtract 15, I've heard Andrew, Trey, Jonathan, a lot of you guys were saying that. What would happen if we subtract the 15 from both sides? Do I get a 0 on one side?
Yes.
Nice. Now, a lot of you are going to try to do something super illegal, so you got to be careful. Can I combine these two terms?
No.
Not at all. One's an x squared, and one's a 15.
3x times 3x.
We could, yeah. 3x times x. There's not 2 3s, or else there'd be a 9. Or parentheses, sure. But yeah, I mean, you can interpret what this says. But here's my question: is it written in this form? Yeah. Oh, where's he? Oh, he's a 0. No stress. No stress. This one doesn't have one, but we're good. We have the quadratic on that side. We have the 0 on this side. We are done. Can you guys take a couple minutes? You can even work together in your groups. How would you rearrange this one? Would you move just one thing? Would you move 2 things? You got to put them in descending order. Ooh, that was a thing with polynomials. I'm going to keep on grading homework. Okay, but you have it. How would you rearrange to get number 4?
Did you smile?
You can keep working on that. I haven't chosen.
That was you today, right?
So that's what we're doing the page on the board, 13, 15.
Hey, wait down. Oh, yeah.
And then the second one is
9. Yeah. That's not what I need. Why is that white? Oh.
Alright guys, thank you so much for letting me come around and grade homework. I think this one was way more efficient than the way we did it last week. Crazy. We need to finish up this worksheet for today so you guys are good for homework. So let's see how you guys did. You had options. How many of you decided to subtract the 5? Okay, you're not wrong. Okay? If you subtracted the 5, you're not wrong, but check how you wrote it, and let me show you why maybe I would have gone the other way. You would have needed to have written this guy first with a negative, because the squared needs to go first. Then you would have needed to write this guy with a positive. It's a lot of sign stuff to keep track of. And then a minus 5. And you weren't allowed to combine any of them because they're all different terms. He's an x squared one, he's an x one, he's a number. This isn't wrong, but for some of you, you might have thought instead of moving the 4x and the 2x squared to the other side, and it might have been easier. Because if you had moved your 4x minus 2x squared, does anybody like having a positive x squared instead of a negative one? Because I didn't. And you could have also gotten rid of your 4x at the same time. You could have actually gotten a 0 on this side with a positive x squared, a negative 4x, and a 5. And to be honest, if we're thinking that maybe factoring is coming back, I would much rather do this one than that one. Now, technically, you could move all these over and have the same signs. I'm just thinking I would much rather. Now, some of you are like, it's backwards. Oh, it's okay. Remember, we can switch around equality statements and we can make it look a nicer way if you like it better. Well, here's the problem, Jerry. This one and that one are the same thing. It's really crazy and it's kind of weird. But I don't like negatives in front of x squared, so I would have actually moved them all to the other side to make it a positive. Yeah, you're still right. It's still in standard form. But normally, part of standard form is, to be honest, we want the ax squared to be positive. If at all possible for factoring, life gets so much easier. Just for you guys to know, if we can make ax squared to be a positive. Now, there's one more thing. There's one more thing that you guys have on your worksheets, which is numbers 5 and 6, right? Okay. Now here's the crazy thing. Didn't we already say that to solve by graphing, we just want to find the x-intercepts, right? And didn't we learn yesterday that we could take something like number 5 and we could write it in factored form and we could find the intercepts? Do we really even need to do the entire graph to see the intercepts? So the nice thing is, you guys don't even necessarily need to do the entire graph. All you really need to do is factor, maybe a GCF, maybe the X method. If you want to do the whole graph, pause. You totally can. If you want to do the whole graph, you totally can. But technically, all I am worried about, guys, are the x-intercepts. Because with the x-intercepts, we can have our solution. I think you guys are good to do 1 through 14. Not part B, but that's okay. We'll keep working on it tomorrow after the 8-5 quiz. Quiz tomorrow only on 8-5. Sound good? 8-5. Stuff we graded today. Look over the worksheets, look over the homework. Catch up if you follow behind. Come in if you have any questions. Bye, guys. As long as you can.
No. I was like, what with the rest of the trip? I was just wait. No. Hang on.
Make sure you bring in your 8.5 stuff. Thanks, Sean.
Hello.
No.
I'm just kidding. That was a prank. I'm so bad.
I missed
Oh, you're right here. And you have Lucas and Wade.
No, I cleared first.
One second, party. Oh, yeah.
Sorry, guys. Let me get out of algebra.